Hello, and welcome to day 2 of my functional Java for Robotics class.
So, let's code Java. So first today, we're going to learn what is telemetry. We're going to explain what telemetry is and why we need it. Then we're going to learn how we use it. We're going to learn how to code basic telemetry outputs and use variables. Next, we're going to learn color sensing. We're going to learn to use telemetry with a color sensor. And finally, we're going to explain today's lesson at the end. So firstly, what is telemetry? Telemetry lets us communicate with our robot. It allows the robot to display the values of its sensors and makes it so we can see what is happening and understand why the code behaves the way it does. So here on the screen, if you had a physical FTC robot, which is what we're simulating, this is where telemetry gets displayed when using your real-life robot. Pretty much you have a phone that connects to your robot and can display all this telemetry information, and you can stop and start your robot from there. So this telemetry thing is kind of like the robot's talking to you. It's saying, hey, yo, I can send some values, you can have it do different things, and you're telling it what information you want it to tell you. So like here in this example, the robot's saying like it's wheels translation, wheels degrees, tools translation, tools degrees, and that it's saying the value it has. This can be really useful as a coder because to understand why the code's doing what it does, you have to actually see these values. Like if I made code that makes it so the robot like reads a value of a sensor and behaves accordingly, I might be really confused when something wrong's happening, but if I can actually see the value of the sensor by the robot communicating it with me down here, I can have a better idea of what might be going wrong in my code and troubleshoot and problem solve to overcome that challenge. So, we will use telemetry today to display the values of a color sensor. This will let us know its readings at different positions on the field, so we can program our robot to stop when it reads certain values of the color sensor. So what we're going to be doing is have the robot say, hey, my color sensor values are this, this, and this. And then we're going to have the robot keep moving until it has a value and it sees this red line and stops based on what its color sensor read. Because this robot has a color sensor underneath it, so as it moves along the field, it can see the color underneath it. So what we're going to do is have the robot move to the side until the color sensor sees a lot of red. So then up here, this is actually where the telemetry displays in the virtual robot simulator. As you can see, it shows the red, green, and blue values of the color sensor. So pretty much the color sensors, you've programmed it to talk to you, and it's actually saying its RGB value, which is the way we measure color, with a certain amount of red, certain amount of green, certain amount of blue. With the FTC color sensor, it's not quite on the scale that RGB values typically are, but as you can see, the red has a very high value of over 45,000 when it's on this red line. So pretty much you have the robot move to the side until red reaches a very high value, and then you know you're on the line, and you want the robot to stop. And up here, the telemetry can show us this red value, show us the green value, show us the blue value of the color sensor and the runtime live, so we can understand why the robot might be thinking and behaving the way it does based on these color sensor values that are communicated to us through telemetry. So telemetry is actually this output right here. So let's explain more about how we can use telemetry. Firstly, to get into telemetry, we have to understand what a variable is. So a variable is a way to store information for later use. You can store strings, numbers, and other types of data. You pretty much name a box in the computer memory and put something inside the box. When you use the name of the box, you reference the data you stored inside. So like here, I have a box that I created named name. And I can put the data Bob inside, and Bob's like a string. String means text. So I'm putting the text Bob inside this box I made called name. And here I made another box called age, and I'm putting the number 35 into the box called age. So if I were to reference these boxes again, they'd have the same value. If I were to reference name, I'd know name has the value of Bob inside of it, and age has the value of 35. So let's imagine I created boxes called B and C. And here's the telemetry code down here that we'll explain in a second. But just based on looking at this, before even understanding exactly what telemetry does, try to consider what the output would be when you run this code and why might this be the case. It's totally cool if you're not right, but it's best to be able to when you go approach new coding, it's best if you can try to infer what it does before learning exactly how it works, because often you'll be brought into new code that you have no idea how it works, and you have to first infer what each step of it does before finally determining the exact way it works. So just try to think this through. What might this code do? I'm going to give you a second to think about it. Cool. So what this code would output is this. So pretty much, first part is we define a variable named b and set its value to 20. Then we define a variable named c and set its value to 10. Then we have this int here. What does that do? Well, when you define a variable in Java, like we are, you must set its type. these variables are whole numbers, which is the integer type. The other common variable types are strings, which are text variables, and floats, which are decimal numbers. So here we're going to set both these variables to ints. And they have these whole values here, so we set their values. So I have a box named B where I put the value in it of 20, and a box named C I create where I put the value in it of 10. So whenever I reference these two boxes again, I'm actually just taking the value out from inside of them. So if I were to reference B like I do here, it's actually referencing this value of 20 that I stored inside of B. And where I reference C here, it's referencing this value of 10 I put inside of the C box. So finally, to display telemetry data, you simply use the telemetry.add data command with the name you want to display next to your variable name. Finally, you update the telemetry screen to show your data with the telemetry.update code here. So here, I'm adding the data B, so that's my label for it, which can make things a lot clearer. So you can see the B here, it automatically puts a colon next to it because it's just a nice label. Like, I could have this be any word I want. And the quotes denote that this is text in here, and we don't want it to change with any different values. We want it to always be labeled B, and then we put our variable here, where it takes the value here, and it reads 20. So therefore, B is our label, which we set here, and the value within this variable box is 20. So the value is 20. And then here our label is C, so it puts C, puts a nice colon for you because this is a nice label. And then we put C, which it opens the box of C and sees that its value is 10. Finally, telemetry update updates the telemetry screen to show this information. So the big thing that's very important about variables is that they can change. So just before we even explain what this code is doing, try to guess what this would display. And just consider that and think about it in your head. And then we'll go over it in a second. So the way this code works is we have B and we have C. You know, we have these two boxes. But down here, B is equal to B plus C. So the B box, which, you know, we have that, we put it here, is equal to the value, we're changing its value by setting it equal to a new value. So to see what value we're setting this B box equal to, we're putting inside of it, we're going to do that equal to B plus C. So we take the current value of B, which is 20, put that down here, and the current value of C, which is 10, put that here. We add them together, because if there's a plus sign, we get 30. Therefore, the new value of B, the new value inside of this B box, is 30. So here, it'll have the label value of B and C, and have whatever's in the B box, which we just said is 30, and then C by itself, which is the value in the C box, which we never changed, so it would just be up here, and 10. So here we go again. We define both variables as integers and set their initial values. We change B's value to the value of what B is currently, 20, add it to the value of what C is, 10. Therefore, B will equal 30 as 20 plus 10 equals 30. And the big thing is, why don't we specify that B is an integer again? Here we have int, why not here? Because you only need to specify what type of data a variable will hold when you first define it. And then, because here we're not defining the variable again, we already have the B box created. This is where we make the B box. Here we're just changing the value inside the B box. So we don't have to say what type of box it is, which is an integer, because we already have the box. Then we're going to display the values of B and C, but this time with different labels. So the quotes, again, the quotes specify that the label is a text value rather than a variable. And we'll learn more about how strings work in the future, because this is called a string, this text value. For now, always use quotes when specifying your telemetry labels. And then finally, we have this nice telemetry update. It's vital that you put this in, and it'll show your telemetry data on the screen. So here's the solution. The value of B and C is 30, and the value of C by itself is 10. So now we're going to do a challenge with telemetry. So you're going to open the virtual robot simulator at this link. Remember, the links for all these videos, this link too, will be in the description of my YouTube video, or if you're using my website, it'll be under the video. So I'm going to open up the virtual robot simulator here. And I've already loaded up to the screen, so we're just going to click on Onbot Java, because we're not using blocks, we're using real Java here. Then we're going to go and delete all the code present, so backspace. And we're going to go to this Google document and copy and paste this code, so Control A, Control C, Control V, there we go. So I'm going to copy and paste that sample code into the simulator, and then to see the results, I'm going to hit initialize and then run the program. So I'm going to go back here, waiting for this to load. So here's my robot. I'll hit initialize, start program. So I get value of B and C, 30, C by itself, 10, just like in that previous example. So let's see what our challenge is. So we're going to use what we've learned to rewrite my sample code to achieve this output shown on the right here. I want you to define two integer variables named f and g and set their values appropriately, and then display their values as shown. Feel free to delete the current variables in telemetry outputs so that they don't interfere. As you write your code, you can use them as a reference though. So let's go back into this quickly. So right now, I'm setting the variables b and c to values. So you should change these to be equal to, f and g and define them differently. Then here I'm doing some math, but you won't need this because that's not what your challenge is. And you want it to display 60 and 40. So you'd have to set these guys as values accordingly. And finally, you're going to change these labels here according to the challenge and change the variables according to the challenge. And finally, update the telemetry to show that change. So I'm going to give you guys a few seconds to work on that, a few minutes, and should have paused the video and then come back when you're ready and I'll go over the solution. Okay, let's go over it. So all we want to do is, so the value of f is, the value of g is, those are my labels, and then the value of f should be 60 and the value of g should be 40. So this, we want it to be f and g, g. The value of f should be 60, so I'm going to set this value to 60, and I'm going to set the value of g to 40. And now I set the b to the current value, okay. So let's quickly go over what are these green things here? What is all this stuff? So these are comments, which means that they do not run. This does not impact my code. This is just a way that you can add labels in. So if someone who didn't make that program comes in, they can have an idea of what's happening. That's like I have where your code should go to make it clear that in here is the code that actually runs when you run your program. So just to be clear, for all the other challenges too, when you run your program, it's in this code if auth mode is active. This is saying if your program is running, it wants to do this. And now this code's formatted a little bit differently because it has like while the auth mode is active too. So just in here where your code runs. This is the code that will run when you hit start. Anyway, so now I want the, I'm going to get rid of the b and c adding together because I no longer have those variables. Then my label should be the value of f is and the value of g is. So let's fix this. So the value of f is, and the value of g is. Then I'm going to put f here. I'm going to put g here. And if I were to run this, stop program, initialize program, start program, the value of f is 60 and the value of g is 40. Now guys, this can be a little bit hard to pick up, setting these variables, doing things. So it'd be a really good idea to spend some time here and experiment with different things. Change these variables, add them together, change some values, learn some things, and keep changing your telemetry to get very used to it. Because knowing telemetry is very important from now on in this class and just in general with working with your robots. So I highly recommend you spend some more time experimenting with these, changing these values, changing the names of the variables, changing telemetry information, and updating to see what you can have happen. I'm just going to go through another example quickly, just to make sure everybody's on the same page here in case you're a little bit stuck. So I'm going to get rid of this. Let's try different variables. So int a equals 20, int d equals 50. Now I want to display these values. But first, I'm going to add 10 to the value of c. So d is equal to its current value, which is 50, plus 10. And now a, I just want to change its value altogether. I don't care what its current value is. I want to set it to the value of d now, plus 10. So I'm going to use some comments here to make it clearer what's happening. So pretty much the value of d is now being set to the value of d. So d is equal to whatever, so 50 plus 10, which is now equal to 60. So d is equal to 60 there. But now a is being set to the value of d plus 10. So now it's like a is equal to, so the value of d is now 60. So a is going to be equal to 60 plus 10, which is equal to 70. So to practice displaying that, we do telemetry dot add data. So we're going to label this. I can put any text I want in here. I can put like apple, banana. It doesn't have to be, it can be whatever word you want that's best for labeling your data. I'm just going to put a here. It'll put a nice colon next to it automatically. And a. And then telemetry. Add data. And then we have D and D. Now the most important thing that often people forget, update. Let's make sure I didn't forget any blocks here. So yeah, telemetry.add data, telemetry.update. If you're ever stuck, make sure to go back, reference the code. Even experienced programmers go back and reference code when they're creating things, because sometimes you forget when you're working with a specific library. Right now we're working with the first robotics library. Like, these is actually coding the different parts of the robot. So like they created what a telemetry is. Like, all these variables come automatically of Java. But when we're working with first robots, like we are here, this is a first robotics robot, then you work with all these different first libraries that they have that can control these different motors, color sensors, and it creates like this telemetry and what it is. So often when you're working with different libraries as a professional coder, because as you program, they'll be like, you're going to use this library to do this. Then you're going to have to reference what specific parts of code do, as you'll always be working with new libraries that you haven't worked with before, at least very often you will. And that's why you often will be referencing things. It's not bad to have to go and Google something for help if you get stuck. So let's initialize and start. And oh no, telemetry is not defined. What happened? Telemetry. Maybe I spelled telemetry wrong. Oh yeah, telemetry. So what's good is it gives you these error messages, and based on these error messages, you can try to troubleshoot. So let's add the E, run it again. And there we go. A is 70 and D is 60, as it should be. Great work. So let's go on to our next part. So here's the solution, and remember that anything with these dashes in front of it is a comment. So these dashes signify a one-line comment, and if you want to go do multi-line comments, you have to put it in between a dash and this little character here. Put your comment, and then this character here again, and another dash. So I believe I have a multi-line comment. Well, this could be a multi-line comment. It's not right now. But since it starts with this character, you don't even need that. You can just ignore this guy too. That's just for formatting because it looks nice. But this is a multi-line comment. Anything I write in here, multi-line. With this guy, it's only one line. If I try to do another line of comment, you can see it's not green. It's not a comment. I'd have to do another dash character, and I can keep commenting. So, view, slideshow. Okay. So now let's learn a little bit about applying this to color sensing. We're not going to go too much into color sensing today. That's going to be our next class's focus. But we are going to learn about how telemetry can be used with a sensor. So delete all of your code present, go to this other Google Doc with the link, remember, is in the description or under my video in my website. And we're going to put all this code in and run it and see what happens. So I'm going to copy this, Control A, Control C, go here, Control A, backspace, Control V. So let's stop this program, initialize it, and start the program. So as you can see, look at that. We got some telemetry going on here, some fancy telemetry too. Wow. Okay. So after seeing this resulting motion and how telemetry looks, look through the code and try to understand how it works. So I'm going to give you guys a few minutes to do this. Well, just pause the video and take a few minutes yourself to do this. But a lot of coding is just trying to look at code and understanding how it works the way it does so you can adjust it to fit your own needs. So I just want you to take some time, look at this code on your own, and try to figure out why it might be working the way it does. You might have some coding experience, so it'll make a lot more sense if you do. But even if you don't, you should be able to look at this and have some idea of what's happening. So just pause the video here, take some time to think through what each line might be doing, and then come back. And remember, this is the part of the code that's running right here, if op mode is active. So this is the stuff you should be looking at to try to explain why it's working. Okay, hopefully welcome back, and let's go through this. So after you think you understand what the code is doing, I want you to try to change it so the robot stops on a blue line instead of a red line. Now, if you code this correctly, your robot should actually not move at all from its starting position as it starts on a blue line. So based on what you inferred about how this code works, well, it's totally cool if you don't get this one right because, you're just inferring things. You're just guessing. I want you to try to make the robot, instead of stopping on a red line like it is now, it should stop on a blue line. And since the robot starts on a blue line, like as you can see, if I reset the field, it starts on a blue line. So the robot just shouldn't move. But that's your goal, to code it so it would keep going until it hit a blue line. So pause the video here, spend some time working on it, and remember, if you get stuck, I'm just going to go through how to solve it so you can come back and I'll explain it all. So hopefully, welcome back. Hopefully you got that working, but if not, let's go through it right now. So let's first explain exactly what this code does, as I think that'll make it easier to go through it. So The solution, let me set up the solution and we'll go through it. So pretty much first we are setting a variable called power to 0.3. So this would be it's defined above with like double. So that's how double is similar to float. It lets you have decimal values. So it's defined up here. And then these guys are all made the boxes for each of these variables too. So like here it creates a variable called R. It creates the variable called G. So like it's making the boxes up here without even giving them a value. And then it sets their values down here. That's another way you can do variables. So you don't actually have to set their value immediately when you create them. You can wait to set their values down here, but you can still give them their type and create that box. It's just like an empty box right now. So what we do is we set power to 0.3 because it's a double, so it can hold decimal values. And then this robot, in this program, it's actually coding each of these motors independently. So we have a front left, a front right, a back left, and a back right this time. And it's setting them all to different powers, and the robot's moving. So what's kind of cool, you might realize, is the robot's actually moving sideways, which is pretty interesting. Look at that, it's moving sideways. How is that possible? That's because it's a mecanum drivetrain. What that means is that these wheels have these really cool like edges on them. They're like very fancy wheels called mecanum wheels. You should definitely look them up if you get a chance, or pause this, look them up. Let's your robot move side to side. We'll go over exactly how to move with a mecanum robot in the future, and how you can make your robot move both sideways, forward, diagonal, spin while going diagonal. It's pretty cool. And if you ever do First Tech Challenge robotics or different robotics, highly recommend you use these wheels because it makes you very versatile if you can move sideways as well as forwards. So pretty much we have the robot move sideways based on setting the powers like this. Then we want to keep checking this. So we set the variable R equal to the value of our color sensor, and we're reading its red value. Here we read its green value, and here we read its blue value. We're just reading its RGB value because that's how the color sensor, you can actually read the color it's reading. Then what we do with our telemetry is we actually display the red, green, and blue. And then FTC has this nice little function called get runtime, which lets us also display its runtime. And then we update the telemetry. So this is a loop that keeps on going while the robot's running, so this will keep on updating. And finally, if it finds that the R value, the red value, is greater than 1,000, the robot's going to stop moving. Therefore, when the R value reaches 1,000, when it gets to this red line, the robot sees that and stops moving. And this break means it's going to get out of this loop here and go here. Finally, it's going to stop moving and just wait there. So you probably inferred like what some of this does. And the big thing is all you would do is you see, okay, R is equal to reading the red, B is equal to reading the blue. And this is stop checking when we see a lot of red. There's comments here too to help you figure it out. I would experiment with changing this to blue. Initialize program, reset field, start program, and look, the robot stopped when it saw blue, which is immediately at the start. So I'll just go see it here too. So we set the values of R, G, and B as variables to the red, green, and blue values of the color sensor. We display the values of the variables as well as the runtime using telemetry, and we'll learn exactly how this code is structured in the future, but this causes the robot here to stop after the value of B is greater than 1,000. So that's our solution. But the big thing is, why did we just do that? We never learned how to use the color sensor. Why even go use that code right now? Well, it is totally alright if you did not understand that color sensing code. As we learn to program, we often look at example code to learn how to do new things. In the future, we will cover exactly what every part of that program does. However, being able to understand in general what an unfamiliar program does and adjust it to fulfill your purposes is very useful. When you program your robots this year for FTC, or just anything in general, you're going to get a lot of sample programs for almost every sensor for FTC, or you'll get samples for other types of coding you do as well. And even experienced programmers rely on these samples and adjust them as needed to perform different tasks. Like this summer, I was doing some data science with coding. And I had this library where I've never used this library before, so it's all these new types of coding functions I've never used. So I looked at examples of other programs and how they did things, and I copied that code, and then I adjusted it to fit my own needs, because like these people who create these libraries actually give you sample code often that you can copy and learn from and use for your own purposes. And FTC, this robot company we're working with, does it as well. So if you do First Tech Challenge robotics this season, for each sensor, that like the color sensor, they have sample programs like this one we just used, where you're able to load it right on up and edit the code accordingly to test things out, which is really exciting and very useful. They want you to look at this code, try to see what it does. Even if you don't fully understand it, you can still adjust it to fit your own purposes. but we will eventually go over exactly how the color sensor works and how to do different things with it. So, will we actually learn the color sensing thing? Yes. Next class, we will cover exactly how to use the color sensor, as well as how to use while loops and for loops and conditional statements like was in that code. So everything in that program that didn't make sense will make sense to you by the end of next class. So that was it for our lesson today. However, if you want to keep working on this, if this stuff's confusing to you, feel free to mess around in this program, go back to the old program and try more things with telemetry. Keep learning about making variables. Experiment, learn a bit, try some things, keep updating telemetry of different variable values. Make sure you really understand how variables work and how the telemetry works, because that becomes vital if you continue with First Tech Challenge Robotics, and even understanding variables in general is essential to programming in general. So keep experimenting with that, keep messing around, and I hope to see you next class. Thank you and have a great day.